In this video, we will talk about a sine rule. Given a triangle ABC, we already talked about the opposite of angle A has a side that's a small letter A. Opposite of angle B would have a small letter B. Opposite of angle C would be a small letter C. Triangle ABC, we can find the area of this by multiplying half times any two sides and an included angle. And in that way, we can form three different formulas that literally talks about the same thing, the area of a triangle ABC. If we multiply this 1, 2, and 3 by 2 over ABC, so this times that, 2 times half is 1, AB's will cancel out, so you're left with sine C over C. If we multiply this one with the second one, we'll get sine A over A. This with the third one, we are going to get sine of B over B. All of these proportions remain the same. So sine C over C is equal to sine A over A is equal to sine B over B. This is called a sine rule. Going back to triangle, sine C over the small letter C. That's opposite of this side. This ratio is the same as the sine of an angle A over the side A, which is also equal to the angle B, the sine of angle B over the side B. Sine rule comes in handy when we're trying to solve for problems that deals with two angles and one side, and two angles and a non-included angle, which we will talk about more in the next video. Find the length of AC correct to the two decimal places. We're given angle B is 58 degrees. We're trying to find AC, which we're going to let it be X. And then we're given an angle C, which is 39, and opposite of that would be 12. So using a sine rule, we can say sine of B over B is equal to sine of C over C. So by plugging in the numbers, we get 50 sine of 58 over B, which we don't know, so we're going to let it be X, is equal to sine of 39 over 12. So in solving for X, cross multiply, so we'll get sine of 39, X is equal to 12 times sine of 58. Dividing both sides by sine of 39, we would get 12 times sine of 58 all over sine of 39, which returns the value of approximately 16.7 on your calculator. Just make sure that these are all in degrees, so your mode should be also in degrees. So the length of AC would be approximately 16.7. Find the measure of angle C in triangle ABC if AC is 7, AB is 11, and angle B measures 25 degrees. So if we create a triangle A, B, and C, we're given that AC is 7, AB is 11, and B measures to be 25. We want to find angle C, which we're going to let it as X. Then we get sine of X over 11 is equal to sine of 25 over 7. Then we get 7 sine of X is equal to sine of 25. Multiply that with 11, so I'm going to write it as 11 sine of 25, dividing both sides by 7, we get sine of x is equal to 11 sine of 25 over 7. So in order to solve for an angle x, we need to put it in arc sine. So that's second sine on your calculator of 11 sine of 25 over 7 returns the value of 41.6. But you have to be careful when you're using a sine rule. We know that sine of a number is also the same. So on a unit circle going back, sine is positive on the first and the second quadrant because of the all students take calculus. We're given this angle of 41.6. Sine of 41.6 is the y value over here, which has the same y value on the second quadrant. So we need to also find this angle. So in order to do that, we need to subtract from 180 degrees minus 41.6, which returns the value of 138.6. So there are two answers on this question. And we need to also make sure that these answers do make sense. 41.6 comes if the triangle is acute. 138.6 comes if the triangle is obtuse. And if we add the angle of 25 on both, it doesn't go over 180 degrees in total. So there are two possible triangles in this case. Find the measures of angle L in triangle KLM. Given that angle K measures 56, LM is equal to 16.8, and KM is equal to 13.5 meters. So it'll be really helpful if we draw the triangle first. So we have KLM. We're given that measure of K is 56, and LM is 16.8. and KM is 13.5. What we're trying to find is the angle L. So using a sine rule, we can say sine of 56 over the opposite side, which is 16.8, is equal to sine of L over 13.5. So we get 16.8 times sine of L is equal to 13.5 sine of 56. To solve for sine L, we need to divide both sides by 16.8. So sine of L is equal to 13.5 times sine of 56 over 16.8. We need to find the angle L, so we want to put it into an arc sine. So arc sine of 13.5 of sine 56 over 16.8. This returns the value of 41.8. Using a sine rule, we always have to be careful. There might be two answers. So if we subtract 180 degrees onto 41.8, we get 138.2. Let's see if this makes sense. If we add 56 degrees, because that's what's given to us, onto 41.8, it doesn't pass 180 degrees, so that's okay. If we add 56 onto the 138.2, it surely goes over 180 degrees, which is an impossible case in a triangle. Therefore, the only solution in this case would be 41.8 degrees.